All right, I'm back. In case you're just joining in, in the I was just working on doing the second round of some problem sets. So I have here a little, this is kind of my little study guide I've been working off of, and I kind of prepared this after I went through all the problem sets the first time. And what I've been doing today is just going through some of the problems again. So the circled ones are ones that I never did. So I didn't do those the first time for whatever reason. Either I didn't have the applet installed at the time, or I just skipped it. Maybe sometimes it was too difficult and I skipped it. And so the most of the ones here I've written here I have done before, and I got them wrong. And I wanted to give myself another chance to do them to see if I had kind of learned the idea from the technique. Now, I was a little nervous when I was doing this because there is the possibility you just remember things. Oh, this is just a trick to solving that. But that has not been the case by and large, that I've had to work off of principles rather than memory for most of these. So it hasn't really been so much of an issue of, well, I just remember how to solve that problem. Indeed, some of these I forgot, and then I also couldn't solve it a second time. So I'm going to jump over now, and let me just load up the problem sets. And I just finished some questions from problem set 4, so now I'm working through some from problem set 5. So I mean, at this rate, I'm going at a pretty good pace, so I should probably be able to finish this maybe in the next, probably Thursday. I'm imagining I should be able to finish all of these. And if I'm able to finish these by Thursday, then that gives me another day to kind of work on maybe some high-level issues, some last remaining skills. I'm thinking what I want to do Monday and Tuesday, last 2 days of the project, is Monday. I think I'm going to do, I think I want to do the problem sets, the midterms and final exam that don't have solutions from this actual class. And then Tuesday, I want to do the final that is from the class that I do have a solution set for, although it's not from this session. And the reason I wanted to do that is that if it turns out that that final is unsuitable because they taught different material in this session, I don't think that's going to be a big problem. But given the difficulty I'm having with this class, any additional difficulty of the classes not being exactly right could be material in terms of making the difference between make or break for the exam. On the other hand, if even if I don't have grades, or like I don't have something to grade myself for those midterms and finals, I can still get a qualitative sense of how well I was doing on them. So I mean, it's not the same as, you know, knowing whether you've met that sort of passing benchmark, but you can do it. And if the exam was like, yep, yeah, I felt pretty good about that, or I had no idea how to answer some of those questions, then obviously we have a bit of a difference there, even if I don't know, let's say that I got a certain score on the exam because I don't actually have the answers. So that's something else that I would say as well, is that when having solutions is important, I think, particularly for these problems, for the learning process. That if you don't know how to do a problem and you don't have the solution and you try and you fail, and then sometimes it's hard to figure out how to do the problem. However, if you're trying to evaluate yourself, often evaluating yourself without feedback is useful, because if the assumption is that you should know it, then you do at least know that, whether you knew it or not, basically from doing the problem. So if you're in a testing situation, you run out of problem sets to work on, you can still make up your own problem sets, or you still work on things that you don't have solutions for, because that will give you a sense of your facility with it. So often students complain about not having feedback. So if they're in a history or biology class, how do you possibly study those things? So I'm back at it now. Some of the people commenting in the afternoon that I was looking pretty tired, and the truth is that I am tired. I don't know. I guess I didn't sleep that well last night, and just feeling a bit fatigued. But I've had a nap and some coffee, so the two of those things together are making me feel a lot better right now. And that's something that I recommend for you too. If you're working and you're just feeling exhausted, I usually like to push through that. I don't usually quit on the first moment I'm feeling tired. So I did try to go through to kind of a good 2-hour-ish mark to take a break. But taking naps is very good for improving your studying, so long as you can not sleep too long through the nap. So if you sleep more than 20 minutes, half an hour, it's going to be you're going to be very groggy after. And two, if you take too many naps or if you drink coffee too late, then you're going to be also have hard time sleeping at night. So not usually a problem. I think last night I just went to bed a little later than I was expecting. So so Noah's back, said, watch the first video, ask off-piste questions. Well, I mean, this is an ongoing project. I know not everyone knows what I'm going on here. I'm still not sure how I feel about YouTube Live as the platform for doing this, just because people are getting pings every time I'm going on live. I don't know whether that's what people want. It's not really a live streaming platform. On the other hand, I don't know how often I'm going to be doing things like these, so to have like a Twitch channel specifically for these kind of projects also seems a little redundant. So we'll just sort of see. I'm not sure how often I'm going to be doing live streaming projects. If I get into live streaming regularly, maybe I'll think about how I want to do that. So with that said, we're going over to question 5.1, and I remember this question. This is probability current, and this one was one that I was challenged with the first time because it was a messy integral, and I remember that when I looked at the answer, it was to just do the integral, and it was messy and things cancel. So this time around, I'm going to do it, and I'm going to stick to it. So what we want to look at here is that let P, A, B, T be the probability of finding the particle in the range A, B at time t. Show that, so the basically time derivative, the amount of probability mass of the particle flowing into and out of a region is given by this curly J AT minus BT, JBT, and JX and T is basically this is the probability current, this J. And so we want to show that, okay, so we have to do two things. We want to first show that this is true, this thing up here. So we want to show that d PAB dt is equal to, I'm going to just do it as a handwritten J because I'm not really that good at writing it. So JAT minus JBT. And we know that J of X T is equal to I H bar 2M psi D complex conjugate minus now I also, another fact about this, I'm not sure I can use this for this thing, but the way of saying this was essentially that this was the kind of amount moving in the imaginary direction was equal to this probability current. So a purely real function, wave function, is not going to be moving, hence our energy states. Excuse me. All right, and so let's sub it in. Do we want to put this in here first? What is PAB in terms of X and T? All right, so PAB is equal to the integral of from A to B. And dP dt is going to be equal to AB ddt dx. All right. Okay, and now we have our Schrodinger equation. Let me expand this out. So we have, again, AB guess I should put the t dependence in here as well. This is going to be, well, we're going to have simple product rule here, which is going to be d dt psi complex conjugate xt psi. I should probably rewrite this the other way. Otherwise, I'm going to get confused about what the ddt is applying towards. So we're going to have psi x and t d dt I star I star x and t. Then we're going to have plus psi star x t d dt psi x t dx. Maybe I'll rewrite this without the x and t's just to make it a little bit simpler. A, B, psi all right. I should probably change these guys over because this is actually partial derivative. Okay. And J of A t minus J of B t is equal to, oh, I'm going to write it that way. That's going to be A dt. And what do I have? Minus this is going to be minus. So what do I see here? Oh, this is pretty similar. Maybe if we evaluate this, we can see what it'll look like. Let's throw down the Schrodinger equation for good measure. So let's see if I can just do it by memory. Oops. Let's see if I can do it by memory. Schrodinger equation. These papers are going to stick up. I believe is minus IH bar d dt. Psi is equal to no, I'm blanking right now. It's with a squared. All right. It's equal to h bar squared 2m. Right, yeah, that's a good idea. D squared dx squared. Ugh. All right. Let me copy this guy back over here. AB psi ddt star plus psi star dt psi dx. And then I don't know whether I want to copy this all out right now. I'll leave that other expression because I think we're going to want to try to integrate this maybe. So I'm thinking about what the strategy is. You know what? I'm going to write this one down too, just so I have them all three in the same place. So this is going to be IH bar over 2M of then we had minus the other one. This was, oh, I wrote them down the same way. They're not the same way. It's this way, yeah. I'll do the opposite here, which is going to be I star T plus I dt T minus psi bt. All right. So we can just remove one of the h bars here, divide out by I. So let's go h divided by h, divide by minus I. So divide by minus I is just IH here. No, but then I'm going to have it under this thing here. I don't know whether that's more useful. All right. So I could substitute these guys in. So I think it's going to remove this. Yeah, let's just try substituting this into this. So we're going to have psi, and then this is going to be conjugate. This is going to be just I h bar 2m d x squared psi complex conjugate. No, let me do it like this. No, I want to keep the derivatives next to each other, so I'll do this. And plus I h bar v of x psi. This is also complex conjugate. Brian's internet adventure saying make sure to get the signs right. Did I make a mistake with the signs somewhere here? Divide by minus I. We're going to get I. H bar is going to lose one of the H bars here. We're going to lower an H bar here. All right. Yeah. You're right. I did miscopy that down. Okay. So, yeah, that will be a minus sign there. So that's a minus sign. We're going to have a minus sign here. Okay. And then I want to do let's go complex conjugate, and we're going to do the same thing here. Ex squared psi I over h bar. That. Complex conjugate of the Schrodinger equation. But would not the complex conjugate of this, if like this is just a function, so if I just make this complex conjugate, I don't think that's going to change anything. Like if this is this is also true. And I've got that there. Complex conjugate of the whole equation. Ryan's Internet Adventures, Triomio. I know you have to take the complex conjugate of the whole equation here. I'm not sure I follow, because this right here would be d dt of some function f of x is equal to this minus I h bar over 2m d squared dx squared plus vxi over h bar of the same f of x. Right? Does this not follow from this? Be true if psi is equal to its complex conjugate. I'm not sure where I follow you here, because if we're dealing with this f of x, I mean, psi is just some arbitrary complex valued function. It could be any function. So if this is true of f of x, then it would have to be true of the complex conjugate of f of x. Perhaps I'm just missing something here. Indicate that psi is always complex. Well, let's look at what we have here. Well, it's completely real if we're dealing with an energy eigenfunction, but I understand your point that it's complex, but I'm not sure why if this is a complex conjugate, then this would also be the complex conjugate. That's, I guess, what I'm trying to get at here. But V is so when you take the complex conjugate, the sign of I switches. Yeah, I know what the complex conjugate means. I guess I'm just kind of trying to parse what there's always a phase factor. But we haven't put the phases in yet. This psi is of x and t, so it's going to include its phase. Well, you might be right, Ryan. I think I'm going to assume your name is Ryan. I think you might be right, but I'm going to try to work through this problem as it makes sense to me right now, and then we'll see what the answer is, because I'm not quite sure. If I take this f of x and I mean, I understand that if we're going to do complex conjugate of this, Schrodinger equation, you'll waste a lot of time. So let me see if I can see what you're trying to say here. But wouldn't you be saying, okay, so let me see if I can understand what Ryan is saying here for helping me out. So we're saying ddt psi star is equal to, well, this was let's just put down the regular one first. Of minus I h bar over 2m d squared dx squared psi. This is my regular Schrodinger equation. And I'm arguing, because this is some arbitrary function, that this is going to be the same thing. And you're arguing that I'm going to, that these are going to be minus what they are on the top. Because this could just be any f of x, right? Just call it, let's call it f of x and t. But I'm not taking the complex conjugate of both sides in this equation. I have d dt, or d dt psi complex conjugate. So I have to put that in terms of this complex conjugate. I'm not complex conjugating this side, if I'm not mistaken here. All right. Let me try it out. I might be wrong. A, B, let's get this. Psi, let's go. I'm going to move this guy over. I minus I h bar 2m. And that's psi dx squared plus that's our first guy. And then we've got our second guy down here, which is going to be the same thing, minus R2M psi complex conjugate psi plus I h bar I think yeah, I feel like you're probably right, Ryan, but I'm not quite sure how the whole thing taking the conjugate of it is going to work. Let me go back up a step. So are we arguing to try to pull this into the complex conjugate? So we're doing this. It seems suspect. I don't think I can do that. There's going to be all these terms here. So Ryan is graciously giving me the tip that I'm supposed to be conjugating this whole thing. But I'm not quite sure how to put that in. I must have to turn this into... Let's see why that would be the case. Oh, I don't think your link has shown up, Ryan, unfortunately. I'm not sure whether you can post links. Sometimes it blocks them on the chat. Yeah, I guess the thing I'm just trying to figure out here is that if this is just some arbitrary function, f of x, then this being replaced with its complex conjugate wouldn't change anything in here. So I'm not sure why I can change something in here to make these minus signs, although I agree with you, that would solve a lot of this mess. Well, supposing you are right, and which you probably are, what would it look like if I were to do that? So we'd have d dt. So it would be this. So we have IH bar. This is equal to... So let's just do this on this. We're going to have minus. Oh, this is already minus. No. No, oh, it's minus here. That's where we had the minus. So this is going to be minus I h bar d dt psi star is equal to, this is just going to be the same. This is the argument, right, that we're doing here. This is the argument here, is that we're complex conjugating this whole mess of this equation, and thus d dt plus I star is equal to, let's divide out by the h bar. So we have h bar 2m divide by minus I, so we cancel the minus, and we'll divide by I. So I guess I'll just put minus I here. D squared dx squared, and then this is going to be minus v of x over IH bar. All right, so what does that give us in our equation if we do it this way? So we're going to go A, B, and we're going to have let me rewrite it out from the start. I'm going to have psi times this whole thing minus. So Ryan's saying, I think your problem is that you assume f of x is any old function, but what that it's saying is that f of x are specifically functions that are unique solutions to the Schrodinger equation. Okay. All right. Yeah. So this is not true of all functions. It would be true for only the functions that satisfy that differential equation. And so I can't just relate it like that. No, that makes sense. No, my problem was just that I didn't see how we were substituting this in, but the complex conjugate doesn't necessarily satisfy the Schrodinger equation just the same way it's put in. Yeah, okay. Now that makes sense. That is helpful. Thank you. All right, so we've got this now. And where is our other guy? Plus psi star. And then we've got the normal solution, which was did I make a mistake here with this? I must have done something wrong here. I've got the same function on both sides. So our ddt, hold on a sec, let me plot this over here. IH bar ddt psi. So divide by I, divide by H bar V minus I by I. This is IH bar, right? IH bar 2m dx squared. And then this one is going to be d of x divided by h bar divided by I, so plus x. All right, I'll just put dx here. So let's group these guys together. So minus I h bar 2m and then we have this minus Vx over IH bar. And then I'll put it on the bottom here. IH bar. Plus u of x. Oops, I forgot to put the other thing here. And then this is IH bar S. So these guys should cancel, which I believe is the thanks, Rodrigo. Well, I do find Ryan's advice very helpful. It's just, it can be a challenge sometimes when working in the chat because people are typing very terse, terse explanations for why something is the case. And sometimes I'm not able to parse it. I have had a few people try to help me with some things and their descriptions were just so brief, I wasn't able to understand their answers perfectly. So let's look at it this way now. So I think I can just pull out this IH bar over 2m. And let's get this. Minus dx. This is our guy, and then we want to do, I guess, integration by parts. To fill this back in. All right. Let me remind myself, integration by parts is u v minus, it should be u prime v. If I'm not mistaken, that is integration by parts. I think that's right. Or did I switch around the u and the v? I should make a flashcard for that. The integration by parts. I keep forgetting the formula. Yeah, okay. So we've got two of these guys. So we can separate that out. And so if we want to turn this thanks, Ryan. Well, I have been suffering this month for sure with going through these problems, but it's been a good experience. I feel like I'm suffering less now than I was the first time around, so making progress. All right, where are we here? Well, let's do this one. Which guy do we want out front? Which way is going to make this solvable? I want this to be v and this to be u, I'm pretty sure. Yeah. So it's going to be AB. Oh, I got to put this after. So this is going to be u is going to have and then this is our minus u. I have to double check how you do this with definite integrals. I've been working because this is a double integral, and I've always been like, oh, am I doing it right with the right bounds? Do I just keep the same bounds? All right, so this is going to be d dx psi star, and then d dx squared psi. Well, the integrating by parts was the suggestion for this particular problem. If we look over the problem sheet right here, it says, hint, remember the time derivatives are determined by the Schrodinger equation. Use integration by parts as often as you need. So often when they say a hint, I just try that and see how it goes. So I will just, this is going to be minus, so I just have to remember to put the plus sign here instead of a minus sign. So we're going to have, this one will be psi ab d dx squared psi plus ab d dx psi star ab no, not psi star. What am I doing? I'm flipping them around. Psi, and then this is d squared. Forget the little 2's at the top. Psi star. Then obviously dx is everywhere, but I'm not going to write those in. It's already too crowded. Can I evaluate this? Well, this is going to be y. Well, the issue with the probability current is that I've got the probability current, if I go back to the start of the problem, I've got the probability current in terms of these time derivatives here. And then this was in terms of, well, this was originally in terms of time derivatives for this. Now I've got these in spatial derivatives. So I'm thinking I need to reorganize it and then flip it back. So this one here is going to go ddx. So this one should also just be, no, I don't think, I got to do them in the right order. So this guy is going to become dx psi valued at a and b. And then we've got TDX. It's getting messy. I remember looking at the solution for this one, and it was very messy. So normally when I start doing stuff like this, I think, oh, I must have screwed something up. But it's quite possible that, well, I may have still screwed something up, but it's quite possible that the actual solution looks something like this. So this time we're going back up one. So this is going to be dx psi star value a and b. And I'll do this again in two parts. So I'll leave this one untouched. And I'll evaluate this one, which is going to be dx psi star. Is there anything that cancels? I feel like these two guys, no. Got them in the wrong order. Do I want to try to, well, let's just do the next step of the integration. I h bar 2m. Well, now this guy is going to go. Is it safe to just, because this is two derivatives multiplied by each other? No, I don't think so. I can't just cancel the derivatives on that, can I? Oh boy. Do I want to do integration by parts again? Sure, why not? Let's try it again. So we've got now dx psi star. I don't know whether that makes any difference. The fact this is also valued in A and B. Oh, oops. Let's finish the integration by parts. And then we're going to plus. This doesn't look like it's helping me. Now we're back to x squared again. No, I don't think that's helpful. We can go look at the problem again. Oh, geez. You know what it is? I wrote these things in terms of, oh my God. dx. I don't know in terms of dt, so dx. Wow. Gotta be careful about that. Okay, so now we should be closer with second derivatives here. I don't know that I want to ditch these A's and B's because obviously dp dt is just going to be like this is obviously true sum. I don't know whether I want to just ditch all these A's and B's because they're just kind of messy. Free will. Actually, I've written an article about free will on my blog. I think I'm trying to remember the name of the actual article, but I wrote it recently, so it would have been written in the last year. So if you go to my articles page, you can find it, and I have written something about what I take to be about free will. So I think that will probably explain my views. All right. Geez. Okay, so let me maybe recopy this guy here over. So I'm gonna remove the A's and B's. So I'm gonna have dp dt, and then I think d. I don't know what the bounds are gonna be on the integral now. Maybe I have to keep them. All right. Let's go like this. A and B, and I got. I'll do this. This right here. Right, that's psi. So we have this, and we want to show it in terms of the. Oh, I forgot the IH bar over 2. Now, this IH bar over 2m, we basically need to get this thing here equal to psi d psi star dx minus. What do I need for A and B? I need to get it to look like that. Man, my pencils are getting dull. All right, it's pencil sharpening time. So give me a second to think on this. All right, let's get back at it. So we do, oh geez, do have these A's and B's to deal with here. All right, and we did the integration by parts. So let me try tackling that again. So I'm going to get the IH bar over 2m. Get that off to the side right now. And we're going to have psi star. Nope. Here we go. So let's see if I can remember how to do this properly. So this one integrated once is going to be and this one is going to be this integrated once times x. And then we have minus psi d dx psi star. And then in this case, we have plus d psi dx d psi star dx. So I think the idea is that these two guys cancel. And we get equals IH bar M. And I forgot to put these are valued at A and B. A and B. So we will put which was equal to our definition. So this should be the right answer. And I think I owe a good deal of thanks to Ryan right now for helping me understand this. I think definitely there's some points of differential equations that I have to kind of remind myself of. That you know, the psi, if it's a solution to it, not every function is a solution to it. So it's these Schrodinger equation will only be true for some functions that hold to that. Okay, and so what are the units of J? Let's do that. All right, well, if I can be here, we've got units of H bar divided by units mass times psi is a unit of length. You know, I'm going to write these as in SI units. I always get meters and mass mixed up. So this is going to be units of 1/√meters. And then this one, d psi dx, is going to be 1/√meters times 1/meters. Is that right? Then minus the same thing. So it's going to be equal to h over kg of, this is going to be meters squared. And this is kg I'll put seconds minus 1. And then this is kg meters squared. Cancel, 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 cancel. And we have it equal to 1/seconds. Which makes sense because this is a dimensionless quantity flowing in time. All right. Here we go. Here's our lovely complex conjugate of the Schrodinger equation right here. Well, to respond to your question about my article, my basic point of the article is that often when we are talking about free will or psychological things, we're talking about emerging properties. So it's not really fair to talk about a system as having a certain property. In the same way that you can't say that like molecules are funny, but things that are made out of molecules can be funny. So free will is sort of a property of complex systems. And I don't think there's anything mystical about it. I think it's just, this is a very useful way to describe those things. And that, you know, even though at some sense it has to boil down to something mechanistic and that feels wrong, that's the thing, that the little gloss there is that to actually break it down into something mechanistic, the thing is so complicated that it's not possible to think using that worked out concept of mechanistically. And so the whole idea of using this free will concept is that it's actually a very good approximation of how you can think about some aspects of behavior. How would I approach this from the book without lectures? Not totally different. I mean, lectures are sometimes better, not always better. I've done a lot of MIT classes with just the textbook. If you have a good textbook, they're kind of similar. I just would have been reading instead of watching the lectures. So you can just imagine everything I did this time, except it was reading. So, I mean, sometimes it's, would I still take notes from the book? I don't usually take as many notes from the book because they're written in the book. Part of the reason for taking notes is just that it's really tedious to look it up in the lecture. And also because reading is a more active task to begin with. You don't have to quite pay attention as much. I'm often writing things down in notes just because I'm going to want to be able to reference it later. I do take some notes just to help me pay attention and to be that kind of check on my understanding. But there's been some times where I've been reading things from this textbook during this process, and I am sometimes taking notes. But well, you can see sections where I'm doing that. Peter Tse has an edX course on libertarian free will based on neuroscience. Yeah, I don't know. I'd have to dig into the philosophy a little bit more, but that's sort of my intuition, is that the thing that I kind of disagree with Sam Harris is that there's a lot of concepts that we know that they have to break down to something else, but that they're still tremendously useful concepts. So I also think that morality is also an emerging concept as well, that it's not baked into the universe, although it embodies certain relationships that are probably useful in the same way that like math is useful as well. So I have some complicated thoughts on that. I'd like to spell it out more, but I think, again, it's kind of difficult to talk about sometimes. All right. And let's just make sure that I got the right units. Time minus 1. So yes, okay. 5.1 down. All right, let's go on now to... I do condense my notes sometimes. I haven't done it in this class, but in the MIT challenge, I did a lot of what I call notes compressions. And the whole idea of the notes compression was also just kind of like quickly overview all of the sort of core concepts, get them in one place. I'm less a fan of it now than when I was doing it then. I don't think it's necessarily a waste of time, but I just think it's somewhat less useful. All right, well, I want to do 5.3 B and C. So let's do B and C. All right, and yeah, and then 5.4. 5.3 B and C, harmonic oscillators oscillate harmonically. Particle of mass m in a harmonic oscillator potential. All right, as initial wave. Okay, so we've got, excuse me. Well, I'm concentrating a little less now. I'm chatting a little bit with chat right now. But I think you have to, I think it's important to not confuse two different things. One is an ability to concentrate, so to maintain like my attention. And I think that that's not actually the case, that there's lots of times where my mind is wandering and I have to focus it back on the task. It's a slightly different thing, which is that I don't stop doing it to take a lot of breaks or to pick up my phone or to distract myself. So that's a slightly different task. So there's kind of staying on task, and then the mental the mental habit of having your attention completely focused on something. And so I think it's a little bit like learning to meditate. That, I mean, there's nothing like anyone can learn to meditate. But it's mostly about most people feel a strong urge to stop sitting at some point, and so it's just about pushing through that. And Pomodoro is great. I don't have any problem with that. I think it's not really, I'm obviously doing longer sessions than Pomodoro, but I mean, I'm also trying to do this in a month, and I'm doing it full time, and so I mean, there's lots of things that are unique to this situation that I think. I think that is true. Yeah, I do try to do the meditation. I've been doing it about half an hour a day, so I do like to keep doing it. But I'm not doing the, I think I wrote an article, I did a video about doing meditation. I've been sticking to the half an hour, pretty much. All right, back to work. I will engage some questions after I finish this math problem. So we want to find the expectation value x. Oh, this is similar to the last thing we were doing. Oh, crap. All right. We want to find x as a function of time. So our psi x of t is equal to 1 over root 2. And we have our phi 0 of x. This one doesn't have it. And then we have an e to the I et over h bar. And then we have this one, which is, plus I. I'm going to put this over here. I phi 1 of x e to the I e over t h bar. And this is, I'm going to put e naught in e1 just so I know that those are different. I don't know whether I want to rewrite this. Let's just take the this expectation. Of getting a little bit of glare in here. Let me just shut the lines a bit more. I gotta say, that's one thing that I have enjoyed less about doing this for CMIT challenges. I have to always control the lighting conditions. So sometimes I'm working in a fairly dark room, even though it's sunny outside. All right. Well, these things are just going to cancel. I don't put the integral first. And we have h bar minus I theta 1 star x minus I 1 t h bar. And then this is times x times So I know some people are asking questions. I'm going to try to work on this for a little bit. I'll take a little break in about maybe 15, 20 minutes. So if you can hold on for then, I will try to answer your questions. Oh, oops. What am I doing? Dx. All right, let's multiply these guys out. So we have x Do I want to put this 1 over root 2 somewhere? Well, I kind of forgot to put it in there, but now I'm somewhat regretting it. We got 1 over root 2 times 1 over root 2. I think it's going to come out 1/2 over here. Yes. And obviously I should get 2 here, so this is like a not. Then we have e to the minus I. So this should just be e to the, should just be 1, because that's going to be 0. E to the 0 is 1. So that's our first term. Now let's do our last terms here. And this should be plus x. And then again, that's going to be 1 canceling here. And now our lovely cross terms. All right, so let's do this one and this one. So I'm going to have, oh, is this going to be enough space? Yeah, let's put it down here. So we're going to have 0 star theta 1, put x over here. theta 1. And there's an I, and then we have e to the this would be I. This is E1 minus E0 T over H bar. And then this guy is going to be negative I. It's going to be negative I theta 1 or theta 0 e to the, and then this one is 0 minus 1 I E0 minus E1 T over H bar dx. So let's just think, these guys are symmetrical, right? So the expectation in x is going to be 0. So we can cross these guys out because of symmetry here and symmetry here. I'm just going to have these guys. So we got 1/2 negative infinity, infinity. Ix. Oh, I forgot the x here. Ix. Okay, let's think a little bit. The fact that these guys are going to be orthogonal, should not cancel them out. I guess not because of this phase business. I feel like these guys are going to cancel somehow. And we're going to get two different exponential terms subtracted against each other. It's going to give us some kind of cosine or something like that. Well, do you want to let's just get the actual E1 and E0. Where's our harmonic oscillator? There's H bar omega. I think it's 1/2 H bar omega and 3/2 H bar omega. It's not on this formula sheet, but I'm pretty confident that's what it is. So we have, now let's try writing it again here. So we have 3/2 minus 1/2 is 1/2 H bar omega. So we have I omega 1/2 t divided by 2. And this one is minus Ix And this one's the opposite. We have minus I omega. It's omega naught. T divided by 2. How do I use this orthogonality to... Because these guys being orthogonal, shouldn't this make this whole dealio 0? I guess we got this x here too. There's something I'm able to do with this to get rid of it, but I'm trying to remember. I don't feel like I can just cross it off. Oh, right. These are just these exponentials. Oops. These exponentials are only in t, so they can just come out. So we have 1/2 e to the I omega t divided by 2. And this is now ix. X, and then we have minus 1/2 minus t. I feel like this is going to turn to 1, but I'm not sure how to show that. Should I be using the lowering or raising operators? That might be good. Yeah, maybe that's the right way to do it. So, okay, 1/2 I omega naught t divided by 2. Now, this is the equivalent of saying now this is one of those add zeros. Let's look at this again. Let me just, I find I have to rewrite my stuff a lot because I'm it's a 0. All right. What if we did, we have to kind of add 0 somewhere. If we added a raising operator here, and then a lowering operator, no. I want something. You know, a dash a is equal to this. So can I do something funny with this to get them into equal to each other? Do I want that? Like this has got to turn into something simple like 1. It can't turn into 0. I can just bring the I out here. Let's do that first. All right. Now we're going to get sines or something like that instead of cosines. One half I e I naught t divided by 2. And then let's try A hat. I guess I can do this. Hmm. Hmm. I'm just rewriting the same thing. This is not helpful. Okay, I'm just gonna get a little water. So Jeremy asked me when I was working on this, do I always approach every class one at a time? No, actually, during the MIT challenge, I was doing usually 3 to 4 at a time. And it's probably better to do more than one class at a time. This project was kind of interesting because I had this specific chunk of time of about a month that I thought I could do this for, that I could put aside and work on it. I mean, if I were only doing it part-time, like if I was doing it maybe like an hour a day or something, I probably would do one class at a time, just because doing 4 or 5 is going to take forever. But yeah, this one here was just unique because I had one period of time and I had a focus goal, so I'm working on this particular class. But I mean, if you're trying to learn a bunch of things, I don't think it's necessarily better to do them totally focused one class at a time. Jeremy's asking, is there a specific way you approach problems? I don't know. I mean, I've been trying to verbalize how I've been thinking about it, so maybe you can see some patterns. How do I stick to my goals? I mean, the fact that I'm live streaming right now provides some incentive not to quit. But I think it's the same thing. You know, you start setting goals and you build kind of a commitment habit. And how do I avoid burnout? Well, I don't know. I've been kind of tired at the end of this project. I've been working pretty hard on it. So I think you kind of have to know your limit. It's a little bit like running a marathon. If you run too fast, run too hot, you're going to quit. But at the same time, if you run more frequently, you'll be able to increase your kind of resting speed. So those would be my answers to your questions, Jeremy. And thanks for reading my stuff. So this question here, Ryan's asking me, do I dabble in languages anymore? Well, I try to maintain my languages. It's easier said than done. This year has been a busy year for me, so I haven't been focusing as much on maintaining the languages. I practice Chinese quite a bit. So that one's probably my best at the moment. I mean, my Spanish is okay. I think the ones that are worse right now are Korean and Portuguese, but that's more just from lack of practice in using them. But it kind of goes on and off. The big thing about languages is just that they're kind of always declining. So maintenance is quite a bit of work compared to some other things. And I have been doing Feynman, not Feynman. When do I start using Feynman diagrams? I think you mean Feynman technique. If you're talking about Feynman technique, I have been doing that. So I'll probably try to go over and find some examples of things and compile a highlighter, but I have done that already. When I was making this guy right here, these ones, a lot of these were Feynman technique. Yes, I've tried to keep up my French as well. I think my French is it's better than my Portuguese and Korean, worse than my Spanish. That's kind of in there. I find that Romance languages often get confusing. You mix them up and stuff. So I feel like I probably need a little bit more. Oh, this thing with all the sheet crossed out. These are, well, after I did all the problem sets the first time, I made a big list of things I need to work on. And as I worked on them, I crossed them out. And then these are problems that I need to do again, of which I'm right now doing this one, 5.3b. So I'm making my way through. This is second pass through of everything. So this problem here, I mean, I feel this cancels to something, but I just can't for the life of me figure out how to prove that. Oops. Ramesh is asking, what about programming? I don't do as much programming as I'd like to. And that doesn't mean I don't do any programming, but it's just become something that I do like kind of in occasional bursts. I really like programming. I just feel like I don't do it as much as I like to. It's probably just because I don't have a project to work on right now. I often find little projects and I'll work on them. I also like to learn some new languages too, because I feel like Python is good, but it's just, I need to get some libraries onto it to learn some things here. Speak from day one. Well, I mean, I was never the speak from day one guy. I guess you could say that's more Benny Lewis's thing. I think speaking early is good. And I think immersion is good. It depends on your goal. I have not actually met Steve Kaufman. I know he lives in Vancouver though. And how do I approach learning programming differently? Well, I do programming as opposed to math problems, so I think that would be the main difference. Programming, like I would distinguish programming from computer science. You're saying I did a computer science degree, but I did a lot of math. So this is actually kind of close to the MIT challenge, whereas it wasn't like I spent a year doing computer programming. I spent mostly a year doing this with some programming projects. You could kind of criticize that as a part of the MIT education, and I think you'd probably be right about that. But the MIT challenge was definitely more math than programming. And I don't feel that was necessarily a bad thing, especially if you want a good theoretical understanding. But if your goal was just to do a lot of programming, it probably wouldn't have been the right approach. I've written before that about on the blog how a lot of people think computer science degree equals you do a lot of programming, and it varies based on the school. But MIT definitely leans a lot more theory, a lot more math, and the fact that they merge electrical engineering and computer science means you end up doing a lot of physics. So like I did some of the prerequisites for this class, which I don't know whether an average CS student would do. Like you don't really need calculus. You don't really need differential equations or electromagnetism or, you know, all that stuff, circuits and whatnot to do it. Yeah, so Jeremy's asking, do I have a general method when learning something? For example, consciously trying to pursue them. Well, I've been doing different things here. I have general approaches to learning. I've written about them on the blog. I'm trying to show kind of how I would approach learning this particular thing. So it's a little bit hard to break that down in a short question. But you know what? After I'm done this project, I could maybe do a little bit of a review of what I did and what I found worked and what maybe my mistakes were. Why don't I learn web development? You know, I used to think that I'd like to do web development. To be honest, I'm less and less interested in web development. Not to say that that's not something that you shouldn't be interested in, but for me, the things that interest me about computer science are less that, I guess. I don't know. So. Main things I wish I knew coming out of university. Oh man, this is like right in my face. I got like the worst position here for this stupid light. It's like the little holes in my blinds just perfectly line up with my face. Main things I wish coming out of university. It's really hard to answer that question. I think one of the main things I wish I knew is just how different the university and academic environment is from, people use real life, but I would say like the kind of typical professional life that people are in. The MIT challenge, I think, was kind of characteristic of my thinking about how learning worked and stuff coming from a school background. So I haven't done as many projects like this recently. I've been doing more projects that are, in my mind, kind of focus more on practical things. And I have some differences in how that works. And so I think there's a lot of stuff that students, they learn how the academic world works, and then they have to go to a professional world or real life, and it works a little bit differently. And so that kind of transition is hard. I don't know, it's hard to summarize that in a short sentence, but I think that is something that's a big difference. How important is planning? Planning is important. I think you can get lost in planning, doing too much planning, but I think at the same time, having a plan and being flexible with the plan is very important. It's easy to get in the weeds and get stuck in doing something and not think about, well, what am I trying to accomplish? So I do actually focus on planning a bit. I don't think these projects come about without some planning. Like, you have to kind of have the idea, I'm going to do this class, I'm going to do it in this time period, I'm going to do this rough kind of schedule, even for this. But there's a lot of adjustments. So if I'll try to find something to summarize or highlight what I've been doing this last month. But there's lots of times where I go in thinking I'm going to do X, and then I do Y instead, and I'm sort of always adjusting and working on those things. Okay, break time's over. I'm going to get back to working on this problem, which I have no idea how to solve. So I don't know. I don't know what this thing is going to evaluate to. Like, I don't know what this is. Like raising, lowering operators. There's like an adding one. There's some trick to getting this to work out. So I'm going to pretend, let's just say that this is one. This is really bad, but let's just say this is one really dubious method. I have no reason for that, but I feel like it's probably has to work out. So it is equal to 1/2 I E I 1/2 T 2 minus, I'll just put this over here, minus I E minus I W naught 2. Oh, what is this in sines and cosines? Well, I guess we'll just put it out. So it's going to be I cosine and then this is going to be plus, this is going to be minus sine. And this is going to be minus I cosine. It's going to cancel, and we're going to get minus, this is going to be minus sine. I think this is minus sine. Did I not make a mistake there? This is I cosine plus. I think that we reverse these. Ugh. What is this now? E to the negative I ix. It's cosine minus sine. But we've got the I. Oh, and then the i's cancels. It gives a negative. Right, 2 negative. Okay, 2 negative, positive, 3 negatives. We got a negative. So this should be equal to sine omega naught t over 2. So to ask our question, it's going to be what is the amplitude of the oscillation? Amplitude. I just have 1 here. So angular frequency is equal to this. So I can answer that part. Did I remove those at some point? I feel it's this step that I'm supposed to get something out of this. So I don't think I'll be able to answer that. All right, let's look at the answer to that because I'm missing something. This is the refrain of this entire project is what am I missing? Okay. What did it do? B. No, where are we? Oh, 3B. Oh, this is 2. 3B. Expectation values defined in the usual fashion. Two sine omega t, this. Okay. Oh, they didn't do some trick. They actually did the full form of it. Ah, crap. Hermite polynomial and A is equal to. Oh boy. All right, so let me write out what we had here. So our two sine, I forgot we can take them as real, so that makes it a little simpler. Sine omega naught t, and then divide by 2. What? Omega naught t. Well, why did this get divided by 2? Oh, geez. This is just, yeah. This is bad math on my part. I'm doing 3/2 minus 1/2, and I have half as opposed to 1. That's where it went. Jeez. Oh my god. So this is why I'm going to fail exam, is I'm making 3/2 minus 1/2 is equal to 1 type errors here. All right. Let's keep going. So 2 sine omega naught t. And we have x dx. So remember, real, okay. And so let's plug these guys in for how. And what do we have here? We have square root of m omega pi. Then we have x squared root 2 over a e to the negative x squared 2a squared. Oh, let's see if I can remember what x squared times a Gaussian is. Crap. I don't remember. Over pi, so we're just pulling everything out for a over a sine. And the a go down the bottom there. Oh. We did a substitution of variables. So this is going to be equal to a squared. So this is our amplitude. All right, that was my bad. Okay, let's try it with C. Again, we better luck there. So, have I learned any instruments? No, not really. I would like to learn some musical instruments, but it hasn't been something that I've done yet. Jeremy, how would you recommend someone learn calculus who has sucked at math? So calculus is kind of its own set of systems. I mean, you need to know algebra, but I found that like you did a lot of stuff in pre-calculus, which was not, I don't want to say was not relevant for calculus, but it's a different kind of way of thinking about calculus. So I wouldn't worry too much about it. I think the key is to just do a lot of problems. The key to doing math well, I think, is to have a lot of patterns in your head for how it works. So do a lot of problems, get really familiar with it. And then also for calculus, especially early on, it's useful to try to visualize the problem so you can get a sense of what you're actually trying to do, because that gives your intuition something to check against. Here, I'm dealing with a lot of stuff that's very difficult to visualize, so I have to land more on my technical skills. But the same kind of idea applies. I'm presumably get better at this. You get different intuitions, although they're not always so obviously visual ones. Yeah, I tend to review at the end of the day. I've been focusing more on previews because I'm expecting people to probably watch the start of videos rather than the ends of them. But if you tune in, you'll see kind of my updates. All right, so let's try it with P. Oh my God. All right, so this is going to be our psi star is negative IH bar. I'm pretty confident it's negative. Let's do H bar over I. Thank you. I'm doing more of the videos for other people. Like when I'm doing by myself, I'm not usually speaking out loud and doing a review. I mean, sometimes it's good to recall, but I didn't do that during the MIT challenge. I'm just doing it because we're on live stream right now. dx. Okay, dx. Now, this guy here is going to be our, let's just pull out our 1/2. We've got psi. Is it minus? Yeah. Then we have h bar over I, dx, and we're going to have y0 plus I, y1. All right. So these are separated, so I can do them separately. ddx, I think I'm gonna need those functions again. So I think this one was just the Gaussian, right? Let me glance over and look at this because they're not in my formula sheet. So we have m a naught pi 1/4. I'm just gonna put a prime here, and this is gonna be plus. I can just divide out the h bar, so just go plus h. And then we're gonna have this guy is what? X root 2 over a e to the negative x squared over 2a squared. Okay. So, I need to take derivatives of these things. So let's do that. Derivative of this is going to be 2x this. So it's going to be h bar I pull this out. Let's pull this out here. And then we're going to have I minus I. Let's do minus I. Minus I. And then this is going to be x squared e to the negative x squared 2a squared. Oh, but it's not going to be. It's going to be divided by something here. What is it divided by? Divided by a squared like that. And take this down. And then it's going to be minus, it's going to be plus here. And what's this guy going to be? Well, we're going to have two terms. One, and the other one is going to be think can pull all of this out. So let's pull it out. What were the two forms? I don't think we want to pull those out. it's going to hit a square root when we get over here. Yeah. Okay. Then we have e to the minus x squared to a squared minus I x root 2 over a minus x squared over 2a squared plus x squared over 2 root 2 a cubed a dx. So let's factor these all out. We're going to have 1/2 h bar root m omega naught over pi. All times. Well, this is going to be 1 should have 6 terms. So we're going to have I x over a squared plus root 2 over a plus this guy. So minus I times I is going to be minus x squared root 2 for a cubed and then we got these guys, so we're going to have minus I x 2x over a squared, and then these guys are going to have minus I x cubed root 2 over root 2 a cubed. These guys cancel the x, so let's I got off the thing here. All right. So we have 4 of these guys. Can I? Let's group terms here. So we've got, I'll just do it in terms of orders of x. So our first one is root 2 over a. Then we have I minus 2i x over a. So we're going to have minus get these guys out of the way. And then we've got our x squared. So let's multiply this guy by root 2 and root 2. So we have and this is where I wanted to memorize my Gaussian integrals here. So these are all separable terms. So we're going to have 4 terms. I did something wrong here. Because we should not have any i's in this. Let's be careful here. We have that multiplied together, so we got rid of a 2 here. It's just x over a squared. A squared. Why did these not cancel? The odd terms. I think these, because these are odd, these get 0 contribution because they're odd functions. So they're going to be anti-symmetric, so they're going to be 0. Yeah, that's how we get rid of them. So we only have to consider this guy and this guy, two even functions. So let me look up integrals of Gaussian. Root pi, do I have more? So this divided by a is going to be root of pi over a squared. So it's going to be root pi a squared. And then let me just go Wolfram alpha. See if I can get something like this. No. I do indefinite. Oh, this is error function. Can I? Oh. Okay, I don't remember what this one is. Do I have to solve it by integrating by parts? Screw it. Let's do integration by parts. So the next one is going to be this. So let u equal to a so we're going to have a minus infinity, positive infinity of, let's get our root 2 over here. This is going to be 1 over root 2. This is bad, right? 1 over root 2. And then we're going to have u squared e to the minus u squared du. And what's the solution for this? They have it here. We just did it. Equals divided by root 2. I'm not sure exactly what this is. I'm going to look it up right now, and then let's go to let's add some of these on flashcards. At least for the first early ones. Oh, I forgot the E, the I. Oh, geez. So we had h bar over 2i. Minus E. I think this is a minus sign. don't know why there's no 2 here. I'm just gonna ask it else right now. All right, so I'm going to cross these out, but I want to make a note. I'll add that back in. So what time is it right now? Yeah, I've been on for 3 hours. I think that's probably pretty good for right now. Let me just switch over here. So I had a few questions. When will the next Rapid Learner session be? I'm not entirely sure. We have kind of a complicated system for having the sessions now. It's a little bit confusing even for me. So the best way is if you go to the rapid-learner-course.com and you join the wait list, you'll be the first to find out. You'll find out about the sessions. What are the core things you need to focus on with learning and aiming to understand? Is it just being engaged with the information at hand? Or do you think learning STEM subjects follow some kind of 80-20? So this is actually kind of a deep question. What does it mean to understand something? And I think we have kind of an intuitive notion of understanding. And this was definitely how I had it. But if you look into kind of the cognitive science of it, this is actually not a trivial question of what does it mean to understand something? How do you tell whether someone understands something or they don't? And there's a couple ways you can parse that. One is like, are you confused or not? And that tends to be related to working memory, which we actually have an article about that coming out soon. But I think typically what we mean by understand is something more like an ability. So when we talk about, let's say, did I understand this problem? It usually means, can I perform the steps of this problem? And more importantly, can I perform the steps in a flexible way, meaning that I don't just have this sequence memorized, but I understand why I'm doing it so that if you were to make small changes to the problem, I could adjust to those small changes. And so given this definition of understanding, I think there's really both definitions, both the confusion definition and this definition, that a lot of understanding is built out of having lots and lots of patterns stored in your head. Now, there's a few ways you can get those patterns. One is by doing practice. So as you practice, you build a kind of fluency. Definitely in math and technical subjects, there's a lot of it, which is fluency, manipulating the symbols, translating things, working things out. There's also a kind of, if for physics particularly, there's a kind of, well, what is the thing you're describing? So the math is a symbolic language to describe some kind of real situation. So you can have an intuition about those physical objects. So This doesn't have to just be about regular things that you experience in your day-to-day life, but, well, what is the wave function actually doing there? What do you expect it to do? What do you need it to do? So when I wrote the original stuff on holistic learning, I often focus on this second definition of understanding, this focus on developing intuitions about things by understanding through examples, through visualizations, through analogies. I do think that this part is important too. And doing the symbol manipulation, doing this kind of understanding is very important, particularly for hard technical classes, because you can't often just guess by looking at the question what the answer is going to be. But if you have both of those intuitions, they act as checks on each other. So if you only have the symbol manipulation, you can get into problems. On the other hand, if you only have a kind of high-level visual intuition, there's going to be a lot of problems that aren't going to be easy to solve just because you have to do a bunch of calculation to get the kind of answer that you want. So I think it's both of those. And I think the way you acquire that is first by doing a lot of practice, and then second by asking yourself why you're doing what you're doing and what is the sort of, in the kind of world you're working with, what are the objects, what are the things that this structure is supposed to represent that you're working with. I think as you get really high into mathematics, that structure becomes less important and it becomes more about the symbol manipulation as you kind of lose visualizability and this kind of thing. But definitely, even in this quantum mechanics, there's a clear visual picture that you can pull. It's not always super easy to tell based on the situation, but I mean, you've got a wave function, it's got some kind of visual pattern, even if it's complex valued in 3 dimensionals. So, I mean, it's a little bit harder to do something like that if you're dealing with like really abstract algebra and things that are just pure mathematical structures that don't necessarily correspond to anything super obvious. So, a big issue a lot of people have with self-teaching versus formal education is lack of access to teachers and students. I mean, that is a problem. Like if I'm looking at this month-long thing, if I'm stuck on this and I don't understand why that solution came up with the answer, well, I can post it on Stack Exchange, but I'm going to have to wait a while to maybe get a response. Whereas I think there is something nice about having a dynamic feedback situation. But I think that the feedback, basically what I would say is that most university education is not all that great for feedback. So this isn't to disrespect teachers or disrespect the having peer environment, but just to recognize, like when I went to university and did actual classes, you very rarely interacted with the professor. You very rarely, maybe you interacted with some students, so that can be helpful if you have a study group and things like that. But very often you were in the same situation that I am, that you don't understand what's happening. You have to get it on your own. And so I really don't think that there's as big a difference, not because feedback doesn't matter, not because teachers don't matter, but because very few formal education things resemble the one-on-one tutoring environment, which, we could all obviously say would be ideal. What are your thoughts on doing too much at once? I don't quite know what you mean by that. What do you mean too much at once? Like too many projects, multitasking? What's the question there? I'd like to implement all these productive habits, sleeping a set time, studying a set amount of time a day, exercising. Oh, okay, like doing all those at once. So I kind of have mixed thoughts. If you're failing, I would do one at a time. That would be my advice. I don't think that it's always necessary to do one at a time, but here's the thing. If you're doing, because I have done this before where you set a bunch of new habits at the same time, but the problem is even habits that seem relatively trivial to do, they can sometimes have interference with each other. They can conflict. So if you're doing, I'm going to study this and work on this and do this and do this and do this, and then you have a really busy day and then you can't do all of them at once, what do you do? So I think it is sometimes easier to kind of do them one at a time. That being said, sometimes there's synergies. So like when I started the MIT challenge, I did tons of habit changes all at the same time, but they were all kind of driven by one overarching goal. So it wasn't like I was trying to pull myself in several different directions. It was, I have this really big goal and I have to change a bunch of behaviors to reach it. So sometimes like sleeping on time, these kind of things, they'll all fit into a larger goal. So the way I would think of it that way, that if you have one big goal that you're trying to achieve, a lot of habits can often line up and you can do them all at the same time, because they're not in conflict. They're all trying to reach the same direction. So where the doing a bunch of things at once tends to cause problem is when you have priority conflicts and you don't know how to resolve them. So for instance, someone was asking about meditating, and I've been doing a meditation habit, and I've been doing it pretty good, except for yesterday I missed it. And it was the first time I missed it in like, I don't know, like 100 days or something, which I felt bad about because I have a little Break the Chain app. And the reason why is because this project has nothing to do with meditation. And so these are two different goals. And so at some point I'm going to run out of time and they're going to, split, and I'm going to have to pick one or the other. And I mean, my meditation habit is not too intense, so I've been able to maintain it despite having other goals. But if I had two really intense goals and they were kind of had opposite motivations, opposite things I'm trying to do, then there might be conflict. Whereas if your whole goal is to do well in school and sleeping on time early and doing X and doing a bunch of things was all part of that goal, then, well, yeah, sometimes you're not going to do all of those things perfectly, but you're just trying to do whatever helps you reach your main goal better. So sometimes that's going to be, well, I should get to sleep on time because I want to focus on this goal. So that would be the way I would think about it, is that you can do more than one habit at the same time, but it works better when they all have the same aligned motivation. If they all have different aligned motivations, you're going to have conflict at some point. You can still do that, but you have to kind of know how to prioritize it and balance it. Noah is asking, when I was learning math and met with a math tutor 2 or 3 times a month, that helps as well. I think it helps a lot as well. I paid $50 an hour, so not crazy expensive. Yeah, tutors can be helpful. I mean, like as much as I'm a proponent of self-education, like tutors are great, and I did them a lot for language learning because you need someone to practice with. And if I were doing this, having a math tutor would be great. I've had a few people like Ryan, who was helping me out a little bit with a problem earlier. So it definitely can be helpful. I don't think it's always necessary. And I mean, sometimes you can struggle to find tutors, and obviously there's the money component. Working with peers can also be helpful as well. But, I mean, it sometimes can be the blind leading the blind if you're doing that. Jeremy's asking, am I interested in philosophy? Yeah, I am interested in philosophy. I think I've read quite a bit about philosophy. I think, I'm interested in lots of subjects, so I'm interested in philosophy. So Jeremy has a comment about it's anti-planning goal setting. Oh, I'm not sure. You're talking about a more specific philosophy. Saying it leads to stress and worry. I don't know. I'm going to say I'm skeptical of a lot of these kinds of arguments. I think that there is certainly a case where planning, can lead to stress and anxiety in a way that it maybe didn't in our kind of ancestral environment. But I mean, we have a lot of planning. I think you need to be a good planner, and you need to be someone who can adapt your plans to the situation. So those are two different skills, and I think you need to have both of them. So I don't think a plan necessarily means you have to restrict your improvisation. Well, I got to stick to the plan. I can't change things. But it's about having that discipline because the plan is about keeping the big picture in mind when you're working on things. The green and white book on your shelf looks like a large pack of cigarettes. Is we talking about this one here? This guy. Modern approach tackling challenges based on formulated faraway goals, detailed planning, reach them, discipline. I don't think it necessarily is a constant worry that you're doing the right thing, but I think anytime you put yourself, the whole idea of goal setting is that you are artificially creating a more straining and challenging environment for yourself so that you would do something that wouldn't necessarily happen spontaneously. I like doing this. I'm glad I'm doing this. I would not be doing this at all if I had not set this goal. And the reason why is because at any given moment, it's not my spontaneous urge to do these kinds of problems and sweat through them. So I do really think that there is a benefit for this goal setting, even if, it's not the case that your moment-to-moment desire of what you want to do is necessarily going to, lead to the best life for yourself. And I think that's obvious, but it's not just because this is utilitarian either. It's just because choosing your environment and choosing how you can structure your environment is very important. Yeah, I agree with you. So Noah was saying about, like, for learning projects, I've actually shifted away from doing them this way. So the way that I did in the MIT challenge was, this is my goal. I'm going to try to do it in a year, and I'll just see how it goes. And the projects I've done after that have all been, I'm going to work on this really intensely for a certain period of time, and let's see how far I can get. And I like that approach better for learning projects because it's super hard to guess how difficult they're going to be. This is a little bit of a weird situation because I'm doing a class. So the class has an obvious, like, did you pass or fail it kind of, barometer of success. But I mean, it is the same kind of idea. I could also be in that situation for this. And I've been struggling with these questions. So it may be the case that I don't get far enough to pass this class, but it doesn't mean that this month was wasted. It just means that it was a hard class and I needed more time. If you just make your goal to practice for an hour, it is a lot harder to not meet it. Any rules to goal setting? I actually have a whole course on goal setting called Make It Happen, which is, it might be on right now. So if you go to Google Make It Happen course, I'm trying to remember whether we had hyphens between the Make It Happen course.com. We'll have, I think we're having a session. It's all about goal setting and my kind of philosophy towards goal setting. I'd like to learn calculus in the next 30 days. How do I plan and set that goal efficiently? So the first step would be to look at some resources. I like MIT's classes, but they're hard. So if Khan Academy is probably better, honestly, but I would say it depends on how comfortable you are. If you're not that comfortable with math, Khan Academy is probably a little bit slower and you can get into it a bit better. The MIT calculus class, it just blazes through because all the MIT students all did AP calculus in high school. So they do, they do differentiation, integration, and a lot of like complex stuff all in the first year. But I think the idea is just pick some resources, start working through it. If you find them too hard, try to find easier resources, break it down, work it out. But again, lots of problems. Same kind of thing I'm doing here. Yeah, so I'm publishing a book. I've already written it. It's just, it takes a while to get the book published. But I've already written it. It's called Ultra Learning. It's going to be out in August. It is basically not about this specifically about learning quantum mechanics, but about this philosophy towards learning things where you set challenging goals and you optimize your schedule for efficiency and you learn it hard, even though it's self-directed, even though, it's dealt that way. And I talk a lot about the science of learning and how there's different principles towards applying learning, about thinking about how you can learn things better, as well as lots of stories of people who've accomplished sort of interesting self-education projects to give you some inspiration about that. So thanks. I've enjoyed, this has been a very, today has been full of chat. And often I feel like I'm doing this by myself. So there's been quite a few people today. So thanks for joining in. I'm going to leave it for today. I'm going to get back at this tomorrow. I've got, I should, I always switch my things. So this is what my to-do list looks like. I've got finish 5.4, and then I've got these ones, but there's a few more of these. So who knows? This probably will take me the rest of Friday. I don't know. I was thinking I could get it done by Thursday, but this afternoon was a real slog for here. So we'll see. But these are also the problems that I found the hardest for the most part for these ones. So there's no problem doing them over again. Yeah, I'll keep working on them. I haven't decided. I really wanted to get this class done in this time period. So I'm sort of in my head. I'm like, should I work a little bit on the weekend? I don't know whether I'm going to do that yet. I'm going to see how it goes on Friday. I do have this weekend relatively free. And my wife is traveling, so I'm here by myself. So what else to do but study quantum mechanics? And so I might work a little bit this weekend, especially if I don't make as much progress this week as I wanted to. You can't just boost force perfect score. If you do one test, you get 100, and then do another, you get 50. The 100 might go down to an 80. Yeah, I haven't actually used Khan Academy a ton. It wasn't really as developed as it was when I was doing the MIT challenge, and I noticed that it was more for earlier level math stuff. I think it's gone a lot further now, though. And I did it through the MIT challenge, so I was using MIT's resources. Yeah, I don't know. One of the things, this has been kind of frustrating, but when I do this live stream, I'm trying to use resources that are not going to cause these videos to get taken down by YouTube. Now, I know I'm probably not supposed to be showing the textbooks, but I mean, it's sort of fair use, and no one's going to have like scans of the textbook to see that I'm showing pieces of these books, or even just static websites. But videos, YouTube has a very sophisticated algorithm for taking down stuff that infringes on copyright. So the MIT lectures are under a Creative Commons license, which allows me to use them in this way because I'm not making any money from doing this project. However, a lot of other learning resources do have copyright, and so I've been unwilling to try to do them on here because then that means that I'm not going to be able to put them broadcast. Often the audio creates a takedown, so I'd have to listen to it with headphones, and it kind of defeats the purpose if you don't see what I'm doing, what I'm listening to. So I don't know how I'm going to handle that in future projects, but I haven't looked in detail in the copyright of Khan Academy, which is some of the reason. I don't know, for anyone who really wants to be painstaking, there's a few times where I am going through things and I'm looking for explanations online, and I do not click on the Khan Academy. I click on some text weaves just because I haven't cleared the copyright and I'm not sure whether I can put it on here. So we'll just see. But I mean, for you, if you're not live streaming, you don't have to deal with that. Yeah, there is more stuff than high school now, though. I was looking, there was stuff for like triple integrals and multivariable calculus in Khan Academy. So it gets better after that. Really love the idea of the MIT course completion challenge. Oh, well, I'm glad you're looking forward to the book. It's been a long time preparing this book. Writing a book through a traditional publisher just takes so much time. So I really hope that you enjoy it. Any advice on procrastination? Well, I mean, the just do it advice is true, but at the same time, I think it's important to realize why you procrastinate on something. And so the procrastination tends to come from you have some aversion to do this task. And so I try to think of it in terms of the only way you could get over this aversion is you have some motivating force that is stronger than the aversion. And so this is just sort of like a basic human behavior that if you are averse to doing something, you must push harder on it than this. And so one of the ways that I kind of create that motivation is by creating projects where there is enough forward pressure that if you don't do it, there's going to be some negative consequence that you don't like even more. And that forward pressure squeezes you forward. But you got to be careful with that, because if you squeeze too much and you feel like you're still not going to be able to achieve your goal. So if you're like, well, there's no way I'm going to pass regardless of how much I study, or if you feel like that, then you might still avoid it. Or if you don't set up your habits and structures to do this work, it might feel like, well, I have this vague sense that I need to study sometime in the next 3 months, but not right now. So I think setting challenging goals and breaking it down into daily schedules and really setting up the schedule such that and the goal such that you need to study all those sessions or you're not going to make it. But if you do study all those sessions, you will make it. That is sort of the key to overcoming procrastination, but it's a lot about fine-tuning those little knobs. So like this class, for instance, I feel like I've been motivated because I feel like there's a chance that I'm going to be able to get well enough to pass the exam, but definitely it's not so easy that if I just skip a bunch of days that I'm going to make it. Like I have to use every hour, and that's how I'm kind of overcoming that procrastination urge. So I'm going to leave it at that. Thanks for all the questions, and I will be back tomorrow morning again to try to see if I can finish some more of these quantum mechanics problems.